Now that I've removed the majority of the material from the knight part, I'm going to create or program what I refer to as a semi-finishing toolpath. I'm going to use a 1/4 inch ball mill or ball end mill, and I'm going to machine the entire part, intentionally leaving 5 thousandths or 0.005 inches on all surfaces of the part. I'll go to the canvas page, knight semi-finished toolpaths, 1/4 inch ball mill. The below images and instructions are to be used as reference while programming the left and right side semi-finished toolpath using a ball or using a 1/4 inch ball end mill. I have a screen capture or an image of the toolpath manager. You can see the 2 additional toolpaths added to this tool list or to this program, and you can see I'm using a 1/4 inch ball mill. These toolpaths will use the boundary that was created and used by the 1/2 inch diameter end mill. This boundary will be used to control the movement of the 1/4 inch diameter ball end mill. This containment boundary will be used by both semi-finishing toolpaths. So here's what the part currently looks like. A couple images of showing us where we are at this time. And this image shows us the boundary that we created and used for the 1/2 inch roughing toolpath. We use the same boundary for this set of toolpaths. So I'll go into Mastercam. I'm going to minimize the existing toolpaths in the toolpath manager. I'm going to make my stock model invisible at this time. And we're going to use a finishing toolpath. If I go back to Canvas, toolpath type, Finishing Equal Scallop. And we're going to select all of the surfaces to drive this toolpath. I'll go to Toolpaths. In the 3D Toolpath section, I'll expand it. And then in the finishing set of toolpaths, I'm looking for Equal Scallop. Select it. And we're being instructed that the default workpiece material does not exist. OK. 6061. OK. For starters, I'm going to select the entire part. So select entities. You can select it different ways. You can triple click on it. That'll select the entire part. Make sure that the entire part is selected. Once you have the entire part selected, select End Selection. And we're going to intentionally leave 0.005 on the wall and 0.005 on the floor. From here, we'll go to Toolpath Control. We're going to use the boundary that we created for the 1/2 inch roughing toolpath. I'll select Containment Boundary. It brings up the wireframe chaining dialog box, or it brings up the chaining dialog box, but because there is no wireframe geometry visible on my screen, it defaults to solids. So I'll change over to wireframe. I'll go to my level manager and I'll make the boundary 1/2 inch flat end mill visible. I'll select it and then I'll select OK. I now have that boundary added to this list. I'm compensating, or I'm allowing the tool to travel to the center like we see in this image. I'll match it to the toolpath control dialog box that we have in Canvas. Everything appears to be correct. I'll now move on to the tool. We're going to add a 1/4 inch ball mill to our tool list. So select Library Tool. My filter is active, so I'll select the filter icon. I'll deselect flat end mills and I'll select end mill to sphere, or ball mill, or ball end mill, equal to 0.25, and then I'll select OK. There's one tool that matches that description. I'll double click on it and it's added to my tool list. We'll need to make some changes. Right click, Edit Tool. On this page, I can accept the defaults for the tool. I'll select Next. Let's start by setting the number of flutes to 2. And we can also turn the coolant on at this level. So I'll select Show More Options. I'll select Coolant. And then I'll set the flood coolant to On. By turning the coolant on at this location, the coolant will be on for all tool paths that use this tool. So from here I'll select OK. And that'll take care of all the changes that I need to make on this page. I'll select Finish. For the SFM, I'm going to set this to 400. For the FPT, I'll set this as 1% of my tool diameter, so 0.25 the tool diameter times 0.01, 1%. My calculated feed rate is 30.56 inches per minute. I'm going to set my plunge rate to half of this, so in the plunge rate field, 30.56 divided by 2. I'm going to borrow the tool name, paste it in this field. I'll go back to the project page, semi-finished pass left face, and I'm going to enter this in as all caps. So, comma, semi-finish left face. That should take care of all the changes that we need to make to this page. So from here, I'm going to jump down to stock. On the project page, it's saying stock setting disabled for this toolpath. Okay, so I'll not make any changes to the stock. For the cut parameters, I'm going to match the settings that I see here. Expand inside to outside. So cut parameters, expand inside to outside, step over percentage. We have a scallop height set to 1/1000th of an inch. So in the scallop height field, 0.001. Double check your settings. Everything appears to be correct. From here, I'll go to steep shallow. We'll reference the project page. From 0 to 90 degrees, the minimum depth 1.25 inches, maximum depth minus 0.013. The minus 0.013 is slightly larger than the radius of the tool. I want the full radius of the tool to drop below the center line of the part. The center line of part is Z0, so this will guarantee that the full radius of the tool drops below the seam or Z0 on the part. So I'll go into Mastercam. I'll activate minimum depth, set it to 1.25, and then for the maximum depth, minus 0.13, slightly larger or 0.005 greater than the radius of the tool. That takes care of all the settings on this page. Linking parameters. Once again, we'll reference the project page. I've got a clearance plane set to 2 inches absolute. I've got minimum vertical retract activated. So clearance plane 2 inches absolute. Type, minimum vertical retract. Everything else appears to be the same. So that'll take care of the settings on this page. From here, I'm going to jump down to planes. And for this particular toolpath, left face should be active for the working coordinate system, tool plane, and construction plane. So what we'll do now is we'll run it in backplot. If we need to make any adjustments, we can come back into the parameters and make adjustments at that time. So from here, I'll select the green check. Mastercam needs to process the toolpath, so I'll go to the toolpath manager. You can see that it is still processing. And what we'll do for the right side of the part, like we've been doing with the previous toolpaths, we're going to copy and paste the proven left side semi-finished toolpath and paste it and make a few adjustments for it to work on the right side. So at this time, you can see that the toolpath has been created. There's minimal repositioning in the Z, so this is a pretty clean looking toolpath. With just this toolpath selected, I'll run backplot. So it does a little work here, and then it moves to the base, and then it starts its motion where it's keeping the toolpath down the entire time. So this is a pretty efficient toolpath. And what this tool is doing is it's getting in and it's removing the material so that it has a nice consistent amount of material for the following toolpaths to remove. And if I look at it from a front view, or a right view, I should say, it was a front view, you can see that the tip of the tool, or the full radius of the tool, is dropping down below the center line of the part, and that's what we want. So from here, I can exit backplot. I can turn off the visibility of that toolpath. And what I'm going to do is I'm going to copy this toolpath, paste it below, and then make a few changes so that it works for the other side of the part. Back inside of Canvas, I'm looking at the project page. The images above are for the left side semi-finished toolpaths of the night. The T-plane that is referenced for the above toolpaths is left face T-plane. To machine the right side semi-finished toolpaths of the night, copy the proven left side semi-finished toolpath. We did that. And paste it after the original toolpath. Change the description in the comment field of the toolpath page and change the T-plane as shown in the images below. So I'm going to go to the tool page of the copied toolpath, and I'm going to change the description or the comment to semi-finish right face. So here we're going to copy the toolpath, right click, copy, right click, and paste. Well, now I need to go into the copied toolpath parameters, so go to parameters, and I'm going to go up to the tool page, and I'm going to change the comment to 1/4 inch ball and mill semi-finish right face, all caps. And then I'm going to go to the planes page. I'm going to leave the working coordinate system set to left face. I'm going to change the tool plane to right face. And then I'll carry over the right face plane to the construction plane by selecting this icon. From here, I'll select OK. We made 2 changes that will allow this toolpath to work on the other side of the part or on the right side of the part. It'll take a moment to process. I'll go back to Canvas. So we just completed these 2 sets of instructions. We have an image of what the part should look like after these 2 toolpaths. So from here, the toolpath is now done regenerating, so I will run just the right side semi-finished toolpath in backplot. And it's a mirrored image of what the left side toolpath looks like. This part is symmetric. We're using the same geometry. So if you were to compare these 2 toolpaths, it is pretty much a mirrored image of the left side semi-finished toolpath. And it looks like it's a pretty efficient toolpath. It's keeping the tool down for the majority of the toolpath. And you can see that it's not machining this surface. Even though we've selected this surface, the reason that it's not touching it or going near it is because of that containment boundary. The center line of the tool cannot go beyond that containment boundary that we created. So from here, I'll exit backplot. I'm going to update my stock for verify. I'll go to simulator options. I'm going to use the stock model from the previous two toolpaths. So remachine between ears. Select OK. I'll save my work. And now with just these two toolpaths selected, so shift select the left side and the right side, I'm going to run verify. It's taking a moment to open up. Now this is the first time that I've run verify today, so I need to make sure that the stop condition and collision is turned on. So stop condition, collision, I'm going to increase the speed a little bit. I'm going to turn down the performance, or lean towards performance over precision. This will speed it up, and then I'll hit play. So the left side is complete, no collisions. And it's actually starting to look like something. And you can see that it can't reach to this area with the current rotation of the rotary. There's a few areas that the tool couldn't get to, but we're going to come in with a smaller ball mill for our final finish pass, and it will clean this up, and it will clean this up. So from here, I'll exit verify. I'm going to create a stock model that reflects what these two toolpaths have done. So with the insertion arrow at the very end of the toolpath group, I'll go to toolpaths, stock model. I'll call this semi-finish. Semi-finish, 1/4 inch. For the initial stock shape, I'm going to select the previous stock model that we created, the one prior to this stock model. So remachine between ears. And then for the source operations, I'm going to select the two toolpaths that we just created. I'll select OK. And it's going to take a moment to process this stock model. Still processing it. And something I wanted to point out. The post will be removed after the fact. I'm going to create a fixture that will hold on to the part, and then I'm going to remove, I'll start by saw cutting the post, and then I'll turn this face to get a nice even or consistent surface finish. So the post, even though we're not machining it, it's ultimately going to be removed from the part. And the part is, the finished part is going to look like what you see here. So Mastercam just created the stock model, and you can see that it's starting to look like the finished part. Now, there are some areas that we will not be able to get to with the tools that I'm using. If you had some smaller tools and wanted to get between the ears and focus on the areas that the tools that we're using can't get to, you could machine it to the exact model.